In this video lecture, we're going to talk about the ModelViewController, which is a design pattern that's frequently used to construct graphical user interfaces. There's not many good written notes for this lecture. If you go to my lecture notes, you can see setting up an MVC application, but for the most part, you're going to have to rely on the video lecture for the ModelViewController. So the ModelViewController basically separates a graphical user interface into three components. The so-called model, which contains the application state, which I'm going to abbreviate as APL, application state. Then you have the view, and that is the presentation component. That's the graphics that display the application state. And finally, you have the controller, which is the mediator between the model and the view, and it takes care of event handling. And there is a dance, so to speak, between these three components. So typically, the controller communicates to the model. So an event happens like a mouse event. It gets communicated to the model, and that changes some part of the model's application state. The model then notifies the view that a change has occurred, and the view updates its graphics. And the controller, in order to figure out where an event happened, is typically going to have to query a view. So there's going to be information that flows from a view to controller. Now, what makes the ModelViewController so handy as a model is that frequently you want to have multiple views of the same application, and that allows you to create new views with the new controller without actually having to have another instance of a model created. And by just having the controllers communicate with the model and then the model communicate with the views, as you can see from this diagram, do not have to know about one another. And that gets to be very helpful because in many large graphical interfaces, you may have many different views of a model. We'll get to that in a moment. But if all the views had to know about each other, you would get to n squared as the number of interconnections that you would have, because you would have n views, and each view would have to know about its n other views. So you'd have n squared connections between them. So if any view changed, it would have to potentially update all n other views. And this gets to be a very problematic from a bookkeeping point of view, and hence this separation was made where the model state was put into the model, and then views were made separate and independent. And the model is meant to be completely graphic independent. The model should have no graphics presentation associated with it. So, as an example of a ModelViewController, how we might implement an interface using it, let's just consider a very simple so-called choice application. So here we have two different views, which is we can choose among 5 different animals, and we have a second view down here, which is a spinner model of it, which allows us, using the buttons to the right, to click through. And you see as I change each view, like here if I go to the next one, tiger got selected, or here if I select dog, dog gets selected down here. So in reality, what I have for this application is I set it up using a ModelViewController. So I had the model, and it contained a single item, which was the current choice, for example, dog. So it had a single state information that was dog. Then there were 2 views, okay? One with, I'll call the button view, which was the one you saw with the radio buttons, and the other that was the spinner view that contained the spinner. And then each of them communicated with the model via their controllers. Now, this is very common that the controller gets bundled up with the view because it's hard to write view independent controllers. So typically the controller is bundled up with its own view. So the button view would have its own controller, the spinner view would have its own controller. But each of these two different views, their controllers would change the choice. So for example, when the button view was selected and it changed to horse, it would update the model to be horse. And then the model in turn notifies each of the views whenever a change has occurred to its application state. And each of them then updates itself, or each of the views updates itself in response to this notification. Okay, so this kind of model that you see back here is very characteristic of the ModelViewController. So this, where we have the notifies, this is often called either a listener pattern or an observer pattern. You'll hear either one used. And you've already been exposed to the listener pattern as part of the event listener model for Java. You remember that events generated events, or there were components that generated events, and then there were event handlers that could register with these event generators to indicate that they wanted to be notified when the event was generated. And this is the same idea with models. When a change occurs, they notify the views. So the views are the so-called listeners or observers, and they register themselves with the model to let the model know that when it changes, they want to be notified of the changes. So let's look at the steps that are involved in setting up a ModelViewController. In fact, you can kind of see here that there's going to be typically a model class, some view classes, there's going to be this notification interface. So typically, what we're going to have is a model class, and it's going to be independent of the graphics. We're going to have view classes, and remember that they're going to typically be bundled with their own controllers. You're going to have some kind of listener interface that is going to allow the model to notify views of changes. And then finally, you're going to have what I would call a glue or main application, which is going to it's going to allocate an instance of a model, allocate instances of the view classes, and tie them all together. And the glue application is going to be the one that contains a JFrame that actually has the window that displays everything. So let's quickly take a look at the steps that are involved in setting up an MVC model. There's typically 4 steps that correspond to, first of all, the model, the view implementation, right here, and the controller implementation, and then, as we said, also the listener interface. So we'll start with the listener interface, and it is something that each view will implement, and it simply contains a set of methods that the model can use to notify a listener that changes have occurred. Then we're going to implement a model class, and it has to have several types of methods. First of all, it has to have so-called query methods that allow views to access the model state information so that they can present the appropriate graphics. There also has to be registration and deregistration methods for the views so that they can register themselves with the model in order to be notified of changes. Then the controller needs to have some methods that allow it to change the model state. And as these change methods change the model state, they need to call a notification method within the model. And what the notification methods do is call methods from the listener interface to let the views know that some change has occurred. And typically, they will save and pass the old values that were changed, because the views will no longer have access to these old values. They will be able to retrieve the new values from the models using query methods, but they won't have access to the old values. An important thing to state here is that you try not to duplicate information. As much as possible, the views don't store model information. They may store a little bit that's absolutely essential, like if there's 10 objects in the model that need to be displayed, there has to be 10 objects in the application or in the view. So there is that kind of rough duplication, but in general the model is going to hold all of its state information, and the view is not going to store any of the model state information. It will query it. Okay, once we have the model, we can start implementing views, and in addition to having to draw the application state information, we need to make sure that we register the view with the model, and we typically do this when we create the view. That's typically done in the constructor. And then the view will implement the listener interface, and each time the model calls it, it can determine whether the view can determine whether it cares about this change, and if so, it will repaint the affected screen regions. If the view consists entirely of predefined widgets, which is frequent, then the widgets will automatically redraw themselves, and all we have to do is update the widgets. Now you notice I said that sometimes the control or the view class may not care about what happens in the model. So an example of this might be if I were having a game and the game had two views. This view, the first view, might be, well, let's see, this view right here might be, say, the game board. And this view right here might be a scoreboard. So if a game piece is moved, that is something the game board view needs to know about, but perhaps the scoreboard view doesn't need to know about that. And therefore, even though the scoreboard view would be notified of the move of the game board piece, it'd probably simply have an empty function body for that method because it's simply going to ignore that particular update. And finally, we have the controller's implementation, which is going to query the view to get information such as where an event occurs, and then it's going to translate the events into change method calls on the model. And as we've already said, typically the controllers will be bundled in with the view class. Now, the best way to understand, I think, the MVC model is to see an actual application and how it might get implemented. So again, let's just go and look at our little simple example here where we are just making a choice of animals, and we have two views, this top view which is a button view and the bottom view which is a spinner view. And if you remember the model, very simple. It has a single piece of information which is the current choice. We have two views, the button view and the spinner view, and then we have to have a notification mechanism by which the model notifies the two views of changes. And we're going to end up with essentially 5 classes. We're going to have one for the model, that will be one each for the button view and the spinner view. We're going to have an interface for the notification method, and then remember we're going to have a glue class, which is going to be the main class that contains everything. So there's going to ultimately be 4 classes and 1 interface that's involved. And if you're wondering about what that glue class is going to look like, so we'll write here the glue class, it's just going to be a J-frame. and it's going to consist of our two views. So we're going to have the button view and the spinner view. And then the button view is going to be a J panel, and it's going to consist of 5 radio buttons. One for the dog, one for the horse, ... up to one for the unicorn. And then the spinner view is actually just a J spinner object. So it's not itself a J panel because it's simply a widget. And in fact, I decided to implement this J-frame. Actually, remember, it has a content pane. So that content pane, I actually gave it a grid layout because I wanted the two components to have equal size, or the two views to have equal size. And I said there was one column, which gave me the 2x1 view that you saw. So let's take a look at the classes now and see what each of them looks like. So first look at the model class. And as you can see, here's that one piece of information that is the choice that it is maintaining. Remember, I said it also had to have a set of registration, deregistration methods, and that was to keep track of our views that are observing us. So I actually have to have a list of observers, and I just created an array list. And the observers are going to be implementing this choice view interface. That's the listener interface that I will use to notify my views of any changes that I make. So then I have a query method called getChoice that's going to allow my views to figure out which choice has been selected. The setChoice is for the controller. It's going to allow the controller to change the or update the choice value. You can see that it temporarily stores the old value of choice so that it can then notify each of the views of the change that has been made and give it the old value. So we iterate through our list of observers and call the update method, which you'll see that the choice view interface will declare. That allows us to update or notify the views of this change. And we are not allowing deregistration, but here our add observer is allowing us to add a view to our observer list. And notice we don't need to know which classes the views extend. Remember, in one case the view was a J panel, the button view is a J panel, and the spinner view will be a J spinner. That's unimportant. The way we're going to communicate with the views is through the listener interface, which is choice view, and each of our views will implement it. So we simply choose to view our views as choice views. So that's the model class. Pretty simple. Just to recap, we have a query method for the view, a method for the controller to change the application state. It also notifies the views of any changes. We have a registration method. We have a piece of data to store our application state, another piece of data to keep track of our list of observers. So next, let's just take a look at that choice view interface. Remember, that's the interface that allows us to have the model update or notify the view of any updates. And in this case, it's a single method called update, and it's simply passing the old choice as a argument. Now, more complicated applications may have multiple updating methods, like a game might have one for moving a game piece, maybe another for updating a score. So you would have to figure out how you're going to partition the changes to the application state into method calls to the views. But this is very simple, so we just have a single method. Now let's look at each of our two interfaces, and we'll start with the easier one, which is the spinner view. And you'll see that, as we said, it extends JSpinner and it has to implement the choice view. And it needs to have a pointer to the model because it's going to have to be able to query the model. So when the constructor is going to take as a parameter the model, or an instance of the model, and it's going to store it, and immediately it's also going to register with the model by adding itself as an observer. Now some of the other stuff here was just to make things nice. Set border and set font were simply setting appearances of our JSpinner. And this set model could be confusing. This is actually setting, the JSpinner itself has a model for displaying the items, which in this case are the 5 choices. So this is what the set model is. It's setting the items for the JSpinner. And then this is the controller for the JSpinner, which is a change listener. And in this case, it is simply calling it's registering the JSpinner generates a change event, and therefore we're adding ourselves as a change listener, and we actually are calling a callback called animal spinner handler. And down here you can see that animal spinner handler simply gets a hold of our model when a change has occurred, and then it sets the choice in the model based on whichever value was just selected. And then down here we're implementing the update method from the choice view interface, the listener interface. And we don't care about the old choice. All we care about is querying the model for the new choice and then setting the value to this choice. So that's the spinner model, or spinner view. The button view, constructed along the same lines, slightly more complicated because it is a J panel, but you can see here it also implements the choice view. And you see we have the 5 radio buttons for each type and the button group that's we're going to put the 5 radio buttons into this button group so that we can make sure they're mutually exclusive. Here again is a pointer to our model, and there's a bunch of things, but we're just going to focus on the things that are important to us. So again, here we save the instance of the model and immediately register with the model, so we'll be notified of changes. And here we're simply creating our radio buttons. So this is just code for creating the radio buttons, and down here we have some code for adding the various radio buttons to the group. The dog will be selected initially. Here we have one of the controllers, which is for the dog, and when the button is selected it fires an action event. So we register ourselves with the dogs, or with the dog button, and ask to be notified when there is an action event. And you can see that we're going to do dog action performed. And we do that with each of the other radio buttons as well. They each have their own action listener, which is a controller for that particular button. So then let's just take a look at one of these. Let's take a look at the dog action performed, and you can see it simply sets the model to whichever choice that we made. So very simple implementation of the controller. And then the update method, that's a little more complicated, or not too complicated. We just have to switch on whichever choice was made. So you see we first get the choice from the model, and then we just switch on the choice, and whichever choice, let's say it was dog, we simply set the appropriate radial button selected method to true. And you might think, well, doesn't that cause another call to be made to the model, because it would seem that a change is being made to the view? But the answer is no. When we call set selected, that does not fire a change event. It turns out that only when we click on a radio button does that generate a action event. And earlier I meant to say when we set selected, it doesn't trigger an action event. So we don't get into an infinite cycle of changing the model, updating the view, and then changing the model again. So that's our implementation for a button view. And we've now gone over the model, the two views, the choice view, and all we have left is the glue application, which I code choice MVC. You can see it is extending J-frame, so it's a J-frame. And we set up a model, choice model. Then we have our constructor, which simply calls init components, and it creates instances of the button view and the spinner view. It does some setting for what happens when we hit the close button on a window. Here's where we set up the grid layout to be a one-column layout, and this is where we added the two views to the content pane. And the very important pack, which invokes the grid layout manager, computes the size of our window and then lays out the components. Finally, we have main, and down here you can see it's simply creating an instance of choice MVC, and notice we set the window that gets returned, we set its visible property to be true. That concludes this discussion of the ModelViewController model. When you're doing your homework, strongly urge you to refer to this discussion, because I know from past experience it is somewhat difficult in the beginning to figure out how to structure a GUI using this MVC model.